Greetings, my name is Sarvid Mohan, and today, along with my group, Dimo, Tushar, and Adam, we will be presenting our medical image analysis platform. This GUI is designed as part of our group assignment to integrate both traditional rule-based image processing methods and modern AI-powered deep learning models for medical diagnostics. The platform provides a user-friendly interface where different diseases can be analyzed from various imaging modalities such as COVID-19 normal classification, brain age prediction, retinal scans, and breast tumor. First, let's look at task 1, which focuses on rule-based analysis tools. Here we rely on traditional image processing methods without using machine learning. The system uses built-in libraries from Python and algorithms for tasks like thresholding, edge detection, morphological observations, and texture analysis. Now let's look at how we're going to do this GUI. First off, the user will upload a medical image. The system processes them deterministically. It undergoes thresholds to which extracts features to assign a tumor type. And for example, in this case, the algorithm identifies the suspicious regions based on intensity variation, size, and shape descriptors. And it says in this case, it's the disease fibroadenoma. As you can see, there are multiple matrix as well in this GUI to provide the user with a more in-depth understanding. While this method is fast, lightweight, and interpretable, however, it is limited when dealing with noisy datasets or complex medical images where handcrafted rules may not generalize well. Okay, now let's move on to task 2, which incorporates AI-powered deep learning. This section of the GUI, a deep learning-based pipeline using EfficientNet V2S architecture for mammogram image classification, and it's supported by GradCam++ to enhance the model interpretability. To ensure the model's predictions are not opaque, explainability was integrated through the GradCam++, an improved version of the gradient-weighted class activation mapping. Basically, the technique uses heat maps that highlight the most discriminate certain regions of an image, contributing to a particular prediction. For example, in this case, an image was loaded by the user. Then through the trained model, it provides the conclusion. And in this case, once again, in this case, it's phyllodes, the other subtype. Along with that, we have a few matrices which provides the user with a more in-depth knowing of what this disease is and how it came about. Now, let's talk further into what makes this project impactful. The integration of both the approach in one unified GUI, meaning both task 1 and task 2 in one unified GUI. This design aligns with the assignment requirement by showcasing both traditional and AI-based vision techniques and by integrating them into a single medical diagnostic platform. That will be all for me. Now I shall pass it to my teammate, Timoharan.
Hello everyone, I'm Dimaharan Prakash, and my part of this project is about spotting retinal diseases on early basis. So, because many eye problems can silently grow and lead to blindness, I use the retinal dataset and my system to check 6 types of diseases, which is normal, diabetic, glaucoma, and optic disc cupping and age-related, and myopia and other parts. It's a multi-label, so one image can have more than one condition. So first, let me walk you all through my task 1. So task 1 is basically a built, sorry, just a minute. So task 1 is a built a rule-based pipeline. Firstly, it tides up the image and crops the image into a certain lighting and improves the contrast. Then it looks for simple clues and strongers the blood vessels and checks on optic disc and the regions which are unusually dark, bright, and yellow. For these, I calculate numbers such as dark percentage, bright percentage, and yellow percentage, and the vessel density. I make decisions using fixed thresholds on the number of values given. There are also sensitive mode, which doesn't use AI. It uses a gentler threshold, so the borderline causes are easier to see. My GUI shows the original image, the pre-processing steps, and also the final layout, and it saves. So I can show you all an example of my GUI working for task one. So as you all can see, I have uploaded an image and it shows me the original and the pre-process and the output. So if I want to go on depth on pre-processing, I can click on the GUI's pre-process to check on the pre-process on detail. It shows me the detections. So as you all can see here, it shows the detections for diabetics and the other diseases which has been detected through this pre-process. And on last, I can show you a metrics table to define my disease on task one. So moving onwards, for my task 2, I have upgraded my system to a MobileNet V3 large and a multi-label prediction because patients may have several diseases at once. I use the output with separate thresholds for each disease. To be safe, I require around 70 to 80% confidence on the disease positive, and if it's 40%, the image is normal. The service runs on a port 5004 and returns to the probability. So let me play all through the task 2. So as I select the image, I can run the analysis for my task 2, and you all can see the disease detected over here, and it gives you a small summary about the disease. And that's it for my task 2. So overall on this, I can say for task 1, it was transparent and explainable, but for task 2, it was scalable and more accurate. So this is on my retinal GUI, and I would like to pass it to my friend Tushar now.
To share your mic.
You're muted.
So, hi everyone. I'm going to talk about COVIDNet project and GUI. And today I'll be presenting COVIDNet based chest X-ray classification together with our custom GUI interface to make the system usable. So, starting with topic number one, that is motivation, the problem statement. As you know, COVID-19 is a global pandemic that put tremendous pressure on healthcare systems. Rapid and accurate diagnosis is crucial. Medical imaging, especially chest X-rays, can show signs of infection. However, manual diagnosis by radiologists can be time-consuming and may vary with expertise. Our goal is to use artificial intelligence to help detect COVID-19 from chest X-ray images. We chose some COVIDNet, an open source deep convolutional neural network designed specifically for this kind of task. So I'll be telling what we did. So we used COVIDX, selecting images from COVID versus normal classification, and then we moved on to pre-processing and resizing the images to standard size. So the GUI and interface. To make this project more usable, we developed a GUI so end users can upload a chest X-ray image and get a prediction COVID versus normal. The GUI also displays sample output, that is, the prediction probability, and optionally pre and post processing steps. For example, showing the image after normalization, maybe overlaying heat map or explaining about the output. This helps the system more accessible for demonstration or for non-technical users as well. So the challenges and we faced is data imbalance is a big issue, more normal or non-COVID images than being positive COVID images. Some images have varied quality that may include the X-ray machine, different sources, and even the noise. This model is not yet clinical graded. Explainability is useful, but we cannot replace medical professionals. So, concluding with the conclusion that COVIDNet offers a strong foundation for automated COVID-19 detection from chest X-rays. Combined with RGUI, the system demonstrates potential for aiding clinicians or for screening in constrained settings. So, moving on to the more expanded version of the GUI. So after pre-processing, the user can run the model with a single click. The prediction results are as displayed clearly on the screen. For example, COVID-19 is detected 92% confidence or normal 95% confidence. To make it more insightful, the GUI can also show an activation map, that is a heat map or an X-ray. This highlights which parts of an X-ray the model focused or whether it's making a decision and when it's making a decision. This makes the tool not just a black box but also something that is transparent and interpretable. Finally, the GUI layout was designed to be intuitive and minimalistic, where the left side will be displaying about the input image preview and the right side will be giving us about the prediction results and confidence scores, and the bottom area will be giving us the additional details like probability chart or status messages. By having this interface, we move the project from being in just an academic model into practical model that can be demonstrated, tested, and potentially used by healthcare staff in the future. Thank you for everything. I'll move on to the next speaker.
Hello, so my name is Adam. Today I'm gonna talk about task for this part, age prediction. So as we know, prediction age from brain MRI is important for study brain health. I built system using the OpenPHP dataset to predict person age while we solving the problems of scanner bias. The bias happens because of the MRIs from different hospitals or machines look slightly different. We use two methods. Task 1, classic process using image processing, like skull stripping and volume measurement. For task 2, we use deep learning with CNN and special database steps to reduce scanner difference. So for task 1, the MR process step by step. First segment brain tissue, then measure white matter and gray matter value. And finally, we use this ratio to estimate the age. As you can see in the eye now, we predict the age and the average of the error. It's like around 60 years. 60 years. So for task 2, we train CNN model and object an OpenPHP dataset. Special part here is our DMPS steps. We adjust the MIR and the rest values so that the image from different scanners look more similar while we keep age related future. Our system runs on plot, takes the outcome file as input, and gives a prediction with confidence range. Key processing includes code scripting, NCST normalizing, and picking the right slides. These steps make sure inputs stay consistent no matter which MR match is used. For the challenge, the main challenge was scanner bias, different machines and add difference that confused the model. We solved try by normalizing intensity and features across seats. This gives us more accurate prediction and prevent the devious relay help the model work across multiple hospitals. Our platform clearly show the improvement between bias and DBAS protection. Our system can process brain MRI scans, predict patient's age, and generate clear report. This project shows that medical AI needs extra care to handle skills and side difference, which are not usually seen in normal computer vision and tasks. Thank you. Now we move to Sarvin. Are muted.
Right. In conclusion, our GUI demonstrates the evolution of medical image analysis from traditional rule-based processing to modern AI-powered deep learning. Task 1 provided us with interpretability and classical methods, while Task 2 showcased the scalability and accuracy of advanced neural networks. Together, these platforms highlight how machine vision can enhance healthcare diagnostics, reduce errors, and support earlier disease detection. With that, I'd like to end our presentation. Thank you for your time.